Hello viewers, in today's class we are going to discuss one important conceptual problem from definite integrals, right? So here we have to find the value of the integral from -3 to 0, and here we have signum of x plus 2 divided by 16 plus x square signum of x plus 2, right? Okay, so now let us solve this integral, but before solving it, let us first see the definition of signum function. Now viewers, we know that signum of y is equal to plus 1 whenever y is greater than 0, and signum of y is equal to 0 whenever y is equal to 0, and signum of y is equal to minus 1 whenever y is less than 0. So this is the standard definition of signum function, right? Okay, and here we have signum of x plus 2 in the numerator and signum of x plus 2 in the denominator, right? So now here what we will do, let us replace y by x plus 2. So signum of x plus 2 is now equal to plus 1 whenever x plus 2 is greater than 0, and signum of x plus 2 is equal to 0 whenever x plus 2 is equal to 0, and signum of x plus 2 is equal to minus 1 whenever x plus 2 is less than 0, right? So here we see that whenever signum of x plus 2 is equal to plus 1, then we must have x should be greater than minus 2, and here x should be equal to minus 2, and here x should be less than minus 2, right? So if we take the real number line and see here, the integral varies from -3 to 0, or the lower limit and the upper limits are respectively -3 and 0. So here we can take -3 and here we can take 0, right? And between -3 and 0 we have this point -2, right? And it lies somewhere here. Okay, so here -2 is the point where we have to break the integral, right? So let us call this integral as I, and we are now going to divide this integral as a sum of two integrals, I1 and I2, right? And I1 is from -3 to -2, and I2 is from -2 to 0, right? And we see that whenever x is greater than -2, right? So in this interval from -2 to 0, in this interval x is greater than -2, and this interval x is less than -2, right? So now we see that whenever x belongs to the interval -2 to 0, that is from -2 to 0, then x is greater than -2, and whenever x belongs to the interval -3 to -2, then x is obviously less than -2, right? Okay, now here let us take signum of x plus 2 as phi of x, right? So we are just denoting this function by phi of x, and just for the sake of writing, and here we have I is equal to, I1 is from -3 to -2, right? From -3 to -2, and for signum of x plus 2 we can write phi of x, right? So we are writing a simpler notation for this function, and here we have 16 plus x square phi x and dx, right? And the second integral is from minus 2 to 0, and we have phi of x for signum of x plus 2, and we have 16 plus x square phi of x, right? Okay, so now we have two integrals to solve, and here we see that whenever x lies between minus 3 to minus 2, then x is less than minus 2. So whenever x is less than minus 2, then signum of x plus 2 has the value minus 1. It means phi of x has value minus 1. So here we can write minus 3 to minus 2, and we have minus 1 as the value of signum function phi of x, and here we have 16 plus x square times minus 1. And when x lies between minus 2 and 0, from minus 2 and 0, then x is greater than minus 2, and when x is greater than minus 2, then this signum function has value plus 1, right? So phi of x has the value plus 1. So here we have plus 1, and we have 16 plus x square times plus 1 dx, right? Okay, so now we can simplify it by writing minus 3 to minus 2, and we have minus sign over here, and we have dx over 16 minus x square, and here we have minus 2 to 0, and dx over 16 plus x square, right? So now we can write these two integrals as minus 3 to minus 2 dx over 4 square minus x square, because 16 can be represented as 4 square, and here we have minus 2 to 0 dx over 4 square plus x square, right? So viewers, here we have two integrals in which the first integral has the denominator 4 square minus x square, and the second integral has the denominator 4 square plus x square. So here we have to use two results. The first one is the standard formula, which is dx over a square minus x square, that is equal to 1 over 2a log a plus x over a minus x, right? And the second result which will be used here, we have dx over a square plus x square is equal to 1 over a tan inverse x over a, right? So at this step we have to evaluate these two integrals. In the first integral we'll use this formula, in the second integral we'll use this result, right? So let us take these two integrals one by one. So I1 is minus, and here we have the value of a as 2, because here we have 4, and we can apply this result, right? So we have minus 1 over 2 times 4, because a is 4, and we have log of 4 plus x over 4 minus x, right? And the limits are from minus 3 to minus 2, right? Okay, so now we can take this factor outside. So we have minus 1 over 8 log 4 plus x over 4 minus x, and the limits are from minus 3 to minus 2, right? Okay, now we can Substitute x is equal to minus 2 over here, so we have log 4 minus 2 and 4 plus 2, here minus x, so minus and minus, this becomes plus, so we have plus 2, and here we have log 4 minus 3 and 4 plus 3, right? So now we can write it as minus 1 over 8, and here we have log 4 minus 2 is 2 over 6, and we have log 1 over 7, right? So now we can simplify it by writing minus 1 over 8, and we have log 1 over 3, and here we have minus log 1 over 7, right? Now taking this negative sign inside, we have 1 over 8 and log 1 over 7 minus log 1 over 3, and here we have 1 over 8 and log 1 over 7 divided by 1 over 3, and this is 1 over 8 log 3 over 7, right? Okay, so here the value of I1 is 1 over 8 log 3 over 7, and here we have used some properties of logarithms, that is log a minus log b is equal to log a over b, right? So here log a minus log b is equal to log a over b, right? Now let us calculate the value of the integral I2. Now I2 can be written as see here the value of a is 4, and we have a square plus x square form, so we have 1 over 8 tan inverse x over a, so we can write 1 over 4. For a we have 4, right? And we have tan inverse x over 4, right? And the limits are from minus 2 to 0. Now we can take this 1 over 4 outside, and we have tan inverse x over 4 minus 2 to 0, and we have 1 over 4 and tan inverse, substituting x equal to 0, so we have 0 over 4 minus tan inverse minus 2 over 4, and 1 over 4 we have tan inverse 0 minus tan inverse minus half, right? And the value of tan inverse 0 is 0, so we have here 0, and we know that tan inverse of minus x is equal to tan inverse of x, and here we have minus, so tan inverse of minus x is equal to minus tan inverse of x for all x belonging to real numbers. So we have here, taking this negative sign outside, so we have plus tan inverse half, right? So now we can write it as 1 over 4 tan inverse half, right? Okay, now here we can also apply one important identity, that is tan inverse of 1 over x is equal to cot inverse of x whenever x is greater than 0. So here for x we have 1 over 2, so we can write 1 over 4, 1 by 4 cot inverse of 2, right? Okay, so the value of I2 is either 1 over 4 tan inverse 1 over 2 or 1 over 4 cot inverse 2, right? So now we can write this integral I as a sum of I1 and I2. So now I is I1 plus I2, and the value of I1 was 1 over 8 and the log of 3 over 7, and I2 is 1 over 4 cot inverse 2, right? And this can further be simplified as 1 over 4 taking 1 over 4 common, so we have half log 3 over 7 plus cot inverse 2, and we can write it as 1 over 4 log square root of 3 over 7 plus cot inverse 2, right? So the value of this given integral is 1 over 4 times log of square root of 3 over 7 plus cot inverse 2, and here we have used the result that a log b is equal to log of b raised to a, right? So this is how we solve this problem.